Okay, so let's go over section 2.5, which is about piecewise defined functions. Well, in short, it's actually also called piecewise functions. What we want you to be able to do is, first of all, you should be able to do function evaluation. That is to say, to find values of a function at given points, which may not necessarily be a number. It could have been some special expression, such as x plus h, or 2x minus 5, so on and so forth. Second thing is you should be able to rephrase absolute value expression to be piecewise defined functions. So you can manipulate and discuss the function properties and values a little bit more confidently. The last thing is something we always discuss whenever you have a function. We talk about domain, the range, as well as the graph of the function. So you should be able to plot graphs of piecewise functions. Let's get started and take a look of what we have here. First, of course, is the definition. The definition of piecewise function is actually pretty straightforward. First of all, it's a function, which means for every single input, you can associate at most one output to it if it's in the domain of the function. But piecewise function has two or more expressions associated with it. And which is slightly confusing because we just said for every input you should only have one output. It's because with each expression you have, there's only a different part of the domain that actually would apply here. So even though this expression, this function have multiple pieces, for every single input, it should only belong to one particular piece, and hence you use that single piece to do the function evaluation. You will never ever evaluate a piecewise function and every single branch of this. So a function defined in this manner is called a piecewise defined function, and usually we call it piecewise function in short. As you can see, the expression we are giving you here, they are both piecewise functions. They have multiple pieces. We don't really care how many pieces you have. As long as it's greater than 2, it will be fine. So the first part is the name of function. It equals, there are several pieces. And the second portion tells you which piece as you should be choosing with the x value that's given to you. So this one tells you if x is greater than or equal to 0, you should choose this piece of the function. If x is less than 0, you should choose that piece of the function. Along the same line of thinking, for this gx, which has 3 pieces for this piecewise function, you would have, let me just re-emphasize, if you have your input to be less than or equal to 2, you choose the first piece. If your input were greater than or equal to 4, you choose the second piece. Otherwise, you choose the piece in the middle. As you can see, our 3 different pieces, the domain, when each piece is defined, they do not overlap with each other. You cannot have one point to corresponding to 2 different values. Technically, I should not say 2 different expressions. I said 2 different values. What could potentially happen is at the intercepting point, you realize, oh, it's greater than or equal to 0 and less than or equal to 0. It seems like 0 was defined twice. But if the expression of the function happen to agree with each other, then you are not defining it twice. You are defining it corresponding to a single value, a single output. Then that's still okay. Well, those are piecewise functions, and how do we do evaluation? Like we said, you just choose the right piece to use. If I have f of 1, you can tell this input 1 is greater than or equal to 0, so that's the piece you are supposed to choose. So you are going to say this is 3 times 1 minus 1, which is 2. But if you were to ask me what's f of 0, I realize f of 0 is also belongs to x greater than or equal to 0 piece. So I would have 3 times 0 minus 1, which is negative 1. If I have f of negative 1, I would realize my input is less than 0. So the first piece, negative 1 greater than or equal to 0, doesn't make sense. So we'll ignore the first row. I only consider the second row. I have my negative 2 times negative 1. Simplification is not required. I've mentioned before, once you get to that step, you get full credit. Of course, if you simplify, as long as it's algebraically sounding, you also get full credit. So just to quickly demonstrate what we have here, we try to do the slightly different expression. So if I ask you what's g of 4, g of 3, and g of 2, I mean, I don't have to calculate the other one. My g function is here, right? So you know my function will cut at the point of 2 and 4, on the left of 2, on the right of 4, and the middle, the between 2 and 4 piece, my expressions, my functions having different pieces, different definitions, so I choose the right one correspondingly. The first one is a constant function, g of x, and I have g of 4, so 4 is greater than 4, so I choose this row. This row says, I don't care what's your input, your output should be 4, so that's what I end up with. If I'm looking for g of 3, 3 falls into this row, so that's what I should be using. I would have 2 times 3 plus 1. G of 2 is where the input is less than or equal to 2, so that's what I end up with. There's no place to substitute my value in, so it's a constant expression. I end up with 3. Well, once we know how to evaluate the function, we talk about how to sketch the graph of the function. But before we do that, I want to quickly warn you that a function or a piecewise function, since it's still a function, for every input you should have some uniqueness when we talk about output. If we have something like this, I have a very huge region that's overlap. So the first piece tells you the function should look like sine x when x is between 0 and 1. The second piece says your function should look like cosine of x when it's between -1 and 3, which include -1 through 0. So between the region, the domain of -1 through 0, your function looks like one expression sine x and also looks like another expression, which is cosine x. Because they are not identical to each other from -1 to 0, so it's going to violate vertical line test, or we would say when x is between 0 to -1 and 0, f of x has conflicting definitions. Sine x and or cosine x. So this is not a function. Or if you want, this is not a piecewise function. But I guess the piecewise part does not matter anymore. It's not a function, so I don't care what type of function you are referring to. Okay, so well, to sketch the graph, which is the last thing we want to take a look at, for the discussion of piecewise function, we will dive into details of graph sketching. So let me record another video for this.